Hey everyone, I'm Eric. What if you could tackle your biggest, most impossible feeling challenges with the same mindset that puts rovers on Mars? Today, we're cracking open the mental toolkit from the book Think Like a Rocket Scientist. And let me be clear, this isn't about learning complex physics or math. It's about a completely different way of thinking, a way that can seriously change your business, your career, and pretty much how you solve any problem that comes your way.
So let me just start by asking you a question. What's the most complicated, high-stakes project you can possibly think of? I'm betting for most of us, launching a rocket is right up there. I mean, you've got a machine with millions of parts, literally fighting gravity, trying to hit this tiny little target millions of miles away. If one single thing goes wrong, poof, billions of dollars and years of work can just disappear in a fireball. The pressure is insane.
So the people who work in this world, rocket scientists, we kind of put them on a pedestal as these super geniuses, right? But the author of this book argues that their real superpower isn't just their big brains. It's a specific thought process, a mental model that is designed from the ground up to deal with massive uncertainty. And here's the best part. It's a process that you, me, anyone can actually learn.
And the author, Ozan Varol, he should know. This guy's the real deal. He was a rocket scientist on NASA's Mars rover missions. He lived this stuff. But after he left NASA, he had this huge aha moment. He realized that the same mental models that let you land a car-sized robot on another planet are incredibly powerful for solving our problems right here on Earth.
So that's what this is all about. We're going to hand you that mental toolkit. Over the next few minutes, we're going to break this whole system down into 3 acts. First, we'll talk about how to dance with uncertainty. Second, we'll get into the core thinking tools you need to take any problem apart. And third, how to totally redefine what failure even means. All right, let's launch into Act 1.
So, here's the funny thing. Our first big lesson from rocket science has absolutely nothing to do with rockets. It's all about mastering uncertainty, and it all starts with 3 little words that we're often afraid to say. I don't know.
I mean, just think about it. From the time we're in school to our careers in the office, we are trained to have the right answer. Saying, I don't know, can feel like you've failed, like it's a weakness or a dead end. But for a rocket scientist whose entire job is to explore the unknown, I don't know is the exact opposite. It's the starting line. It's a sign of curiosity. It's where all the good stuff begins.
And this leads to a really crucial insight. Being wise or smart isn't about having all the answers locked and loaded. It's about knowing how to ask the right questions. Picture a typical meeting at work. The boss asks the question and crickets. Everyone's afraid of being wrong. But at NASA, it's the total opposite. An engineer shows a design and the room just erupts with questions, poking holes in it. What about this? Did you think about that? Every single question makes the project stronger.
Okay, so how can you actually use this in your life? You start by learning to separate the cold, hard facts from the things you just assume. For example, you might have this assumption: I have to work out for an hour every day to get fit. But is that really a fact? A rocket scientist would treat that like a hypothesis. Let's test it. Try working out for just 15 minutes a day for a couple of weeks and see what the data says. When you turn your assumptions into little experiments, the anxiety just melts away and you actually start making progress.
All right. Once you're comfortable living in that I don't know space, you need the right tools to find your way. So in Act 2, we're opening up the rocket scientist's toolbox to grab 2 of their most powerful weapons. The first tool is a total game changer. It's called first principles thinking. Now, most of us think by analogy. We look at what our competitors are doing and we try to do it just a little bit better. That leads to small, incremental improvements. But first principles thinking, it's about ignoring all that. You break a problem all the way down to its most basic, undeniable truths. You reason up from there, and that's where breakthrough innovation comes from. The perfect example of this is Elon Musk. When he wanted to build rockets with SpaceX, everyone told him it was impossible because they cost way too much. But he didn't ask the analogy question, how much does a rocket cost? He asked a first principles question, what is a rocket literally made of? And when he did the math, he found that the raw materials, the aluminum, the titanium, the carbon fiber, only cost about 2% of a finished rocket's price. The breakthrough wasn't cheaper materials, it was realizing the real problem was in the manufacturing, not the parts themselves.
Okay, tool number 2 is like having a supercomputer in your head. It's the thought experiment. This is your way to run endless simulations and scenarios without any cost or any risk. Rocket scientists live in this world. They're constantly imagining what could go wrong. A solar panel doesn't deploy, a sensor fails. Not to freak themselves out, but to have a plan B, C, and D ready to go.
And here's a super practical thought experiment you can use tomorrow. It's called the premortem. Sounds a little dark, but it is brilliant. It's so simple. Before you start a big project, you get the team together and you say, okay, let's time travel 6 months into the future. This project was a complete and utter disaster. Now, let's write down every single reason why it failed. It's an amazing way to uncover all those hidden risks so you can deal with them before they actually happen.
So, we've learned to embrace uncertainty, and we've armed ourselves with some killer thinking tools. Now it's time for Act 3, which might be the most counterintuitive and challenging part of this whole mindset, completely changing how we look at failure. This story from the book just blows my mind. When engineers are testing a new rocket engine, their goal isn't just to see if it works. Their goal is to find its breaking point. They push it harder and harder and harder until, kaboom, it explodes. And when it does, the engineers cheer. They high-five each other. Why? Because that explosion wasn't a failure. It was perfect, beautiful data that tells them the engine's absolute limit. A test that runs perfectly, well, that doesn't teach them anything new.
This brings us to a really important idea, the difference between a stupid failure and an intelligent failure. A stupid failure is making the same mistake over and over again. An intelligent failure is totally different. It's when you fail on purpose, in a way, while you're exploring new territory. You do it at a scale you can survive, and it gives you data you couldn't get any other way.
So what does an intelligent failure look like? Well, first, it happens when you're pushing the boundaries, trying something new. Second, the scale is controlled. It's a calculated risk. You're not betting the whole company on it. And most importantly, it's designed for learning. The goal isn't to avoid failure at all costs. The goal is to design smarter failures so you can learn faster than everyone else.
And this brings us to a super practical strategy. Instead of seeing your big goals as one giant, terrifying leap, break them down into a series of small, low-cost tests. Let's say you're thinking about a career change, maybe becoming a programmer. Don't just quit your job and sign up for a crazy expensive boot camp. That's a huge risk. Instead, spend a weekend doing a free online course. That's a small test. If you hate it, that failure cost you almost nothing, but the data you got about yourself is priceless.
All right, we have covered a ton of ground. So let's bring this rocket in for a smooth landing and just quickly recap the key takeaways from this whole mental launch guide.
So here it is, your brand new toolkit straight from the mind of a rocket scientist. Number 1, embrace uncertainty. Make "I don't know" your favorite phrase because it's where everything starts. Number 2, deconstruct your problems. Use first principles to find the real truth and use thought experiments to prepare for the future. And number 3, pursue intelligent failure. Turn those big risks into small tests and treat every single outcome as valuable data.
Look, thinking like a rocket scientist isn't really about being a genius. It's about having a better process for dealing with the things that feel impossible. It's a much more courageous way to approach your work and your life. So I'll just leave you with this one last question. If you took your biggest challenge right now and handed it to a rocket scientist, how would they even begin to think about it?
If you enjoyed this breakdown, it would really help the channel grow if you hit that like button, subscribe, and maybe share this with one person who you think would get something out of it. And hey, if there's a book you want to see me break down next, just let me know in the comments. Thanks for watching. I'm Eric, and I'll see you in the next one.